Good day, Sir Jeremy Plata. I am Quinto Delby Flores, and we would like to discuss our reporting considering the Fibonacci sequence, and we will discuss also the concept and examples and our insight about our discussion. The Fibonacci sequence is a sequence in which each number is the sum of the two preceding ones. Numbers that are parts of the Fibonacci sequence are known as Fibonacci numbers. Commonly denote the sequence commonly start from 0 and 1, although some authors start in sequence from 1 and 1, or sometimes, as did Fibonacci, from 1 and 2, starting from 0 and 1, and the first few values in the sequence are 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, and 144. The Fibonacci numbers were first described in Indian mathematics as early as 200 BC in work by Pingala on enumerating possible patterns of Sanskrit poetry formed from syllables of two lengths. They are named after the Italian mathematician Leonardo of Pisa, also known as Fibonacci, who introduced the sequence to Western Europe mathematics in his 1202 books Liber Abaci.
I am Charlene Indiva, and I am answering the question number 1, which is what math concept is fully focused on your assigned video. So our topic is the Fibonacci sequence. So the Fibonacci sequence is a mathematical concept that is fully focused in the field of number of theory and mathematics. It is a sequence of the sum of two preceding ones. So the Fibonacci sequence is simple to calculate. The series starts with 0 and 1, and its subsequent number is the sum of two preceding ones and goes so infinitely. So example, 0 and 1. 0 plus 1 equals 1, 1 plus 1 equals 2, 2 plus 3 equals 5, and so on. So that's the Fibonacci sequence. So the sequence has numerous properties and applications in various areas, including mathematics, biology, art, and also the computer science. So some of the topics related to Fibonacci sequence that are often discussed include its closed form, expressions, property of the golden ratio, applications in nature and art, and its role in algorithms and computer science.
The math concept is fully discussed on the video is all about Fibonacci sequence. Fibonacci sequence is a typed series where each number is the sum of the two that precede it. Fibonacci sequence is the sequence that follows the rule that each number is equal to the sum of the preceding two numbers.
The math concept that fully discussed in our group is the Fibonacci sequence. The Fibonacci sequence is the set in integers that start with 0, followed by a 1, then by another 1, then by a series of steadily increasing numbers. The sequence follows the rules that each number is equal to the sum of the preceding two numbers. That's how works the Fibonacci sequence or Fibonacci numbers.
Math concepts fully discussed on the Fibonacci sequence are: first, the phi and the golden ratio; second, patterns and ratios; third, Fibonacci and spiral; fourth, Fibonacci numbers and nature; fifth, Bennett's formula.
The concepts of Fibonacci sequence are all about the patterns and sequence of the things that surrounds us. One of example of this real-world case that would show the concept is the spiral galaxies. Not surprisingly, spiral galaxies also follow the familiar Fibonacci pattern. The Milky Way has several spiral arms. Each of them, a logarithmic spiral, is about 12 degrees. As an interesting aside, Spiral galaxies appear to defy Newton physics. As early as 1925, astronomers realized that since the angular speed of the rotation of the galactic disk varies the distance from the center, the radial arm should become curved as galaxies rotate. Subsequently, after a few rotations, spiral arms should start to wind around a galaxy, but they don't, hence the so-called winding problem. The stars on the outside, it would seem, move at a velocity higher than expected, a unique trait of the cosmos that helps preserve its shape.
My example of the sequence of Fibonacci is the set heads, because the head of the flower is also subject to Fibonacci processes. Typically, seeds are produced at the center and then migrate towards the outside to fill all the space. Sunflowers provide a great example of this spiral pattern. So, nakaingon ko nga ang spiral ay ang seeds ang one of the example kay if you look the center or if you look the head, so kung tanaw na to ang center and the head of the sunflower, the pattern that he will emphasize is the spiraling pattern. So kung para ma-prove yun, try ninyo tanaw ang ulo or ang bulak or ang sentro sa seeds sa sunflower, diyan ninyo ma-emphasize or makita ang spiraling patterns.
Example of sequence of Fibonacci animals' bodies. Even our bodies exhibit proportions that are consistent with the Fibonacci numbers. For example, the measurement from the navel to the floor on the top of the head of the navel of the golden ratio. Animal body exhibit similar tendencies include dolphins, the eye, finch and tail are full of golden section, starfish, sun dollars, sea urchins, and honeybees.
Fibonacci sequence is a simple yet profound pattern. The sequence begins with the numbers 1 and 1, and then its subsequent numbers is found by adding the two previous numbers. For example, 1 plus 1 equals 2, 2 plus 1 equals 3, 3 plus 2 equals 5, and so on.
Truths or certainties are fundamental principles in mathematics that are universally accepted as being true without the need for proof. These truths serve as the foundation for all mathematical reasoning and are essential in various fields. Overall, mathematical truths are the bedrock upon which the entire field of mathematics is built. They are characterized by their universality, logical consistency, and indispensability in both theoretical and practical contexts.
Mathematical truths are the kinds of statements that are both certain to a high degree and also easily knowable by humans through the practice of mathematical proof. Each of these aspects of mathematical truths is explained by one of the two views above but not the other. And the second, certainties. Mathematical certainty, something that is completely certain to happen. Mathematical example from the corpus mathematical certainty. We can possess a mathematical certainty that 2 plus 2 make 4, but this rarely happen to us. Difference between certainty and truths. Certainty which will always fall short of truth. In fact, logicians have shown much of even our simplest mathematics is not and cannot be anchored in the realm of proof. Remember, perched atop mathematics is physics, our most fundamental scientific conception of the universe.
Answer is something that will definitely happen. Victory is now. A mathematical certainty synonyms unrelated towards some things that is certain or likely to happen.
The kind of truth you get in math is a rather low level of truth. Truthology truth. Physicists use math as a tool to whatever extent they are able to put truth in that the beginning math allow one to derive consist result. The choice of what math to use has to be part of the input and empirical choice.